Welcome to Exploring Triangles and Rectangles. Earlier we've looked at the basic shapes, squares, rectangles, and parallelograms. Today we're going to incorporate triangles into our discussion of the shapes and their relationships. I want to start simply with the formula that we've already learned, and I just want to get you to practice using them and be comfortable writing them and what they represent. So we started with the perimeter of a square, and we decided that for a square with 4 equal sides, we were going to do the number of sides times a length. For other polygons and perimeter, we were going to say side, depending on how many sides the polygon has and if those sides are different. With an equilateral triangle, remember, we said that because all the sides were equal, we could do 3 times the length. We've also talked about the perimeter of a rectangle. And a perimeter of a rectangle, remember, equals length plus width times 2. In the same situation, we've talked about area of a rectangle. The area of the rectangle being length times width. Then we moved on to parallelograms, and we said, well, we can figure out the perimeter of a parallelogram by also using length plus width times 2. The difference was in area, we were talking about base and height. So this is where we've come so far with perimeter of polygons, squares, rectangles, and parallelograms. We've also found the area of both rectangles and parallelograms, and today we're going to focus on triangles and their relationship. And here's how we're going to do this. We will still refer to the measurements of a triangle. Any side of a triangle can be its base. So even if I take my shape and turn it on end, any side can be the base. What we typically view as the bottom here can be the base, or if I spin it on its end, if you will, this side can be its base. Any side of a triangle can be its base. And I'm just going to delete these so that we get them off our field of vision. And we're going to say that the height of a triangle is the perpendicular line segment. Remember, perpendicular is the upside down capital T. That joins the base to the opposite vertex. Remember that the vertex are the points, if you will, in our triangle. So the height in our situation, in this example, the height of our triangle would be here in green because this is our perpendicular line that connects the vertex to the base. So we have our base and we have our height. And we can use that information to develop a formula for the area of a triangle. And this is how we'll do it. If I take a rectangle, in this case I've used blue and red to create a rectangle. Remember that the area of a rectangle equals length times width. 1, 2, 3, 4, 5, 6 is my length. And my width is 1, 2, 3, 4, 5. So the area of this particular rectangle is 30 square centimeters. To get back to triangles, if I take my rectangle and these triangles happen to be mirror images of one another, what I'm going to do is I'm just going to slide the red guy out of the way here. And I'm going to push him off to the side for a minute. What I've done is cut my rectangle in half. I'm going to estimate the area of my triangle before I do anything else. And we'll do that the same way we estimated the area of a rectangle. We'll count the squares that are half or greater. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to stop at 15. So I'm going to estimate that my triangle has an area of 15 square centimeters. Now, to go back to my red triangle friend, If I flip him upside down, you can see that they're mirror images. If I put him right over the top, cover it completely. Remember, my rectangle had an area of 30 square centimeters. So let's find the area of a triangle. The formula for finding the area of a triangle is base times height divided by 2. And we divide it by 2 because those two triangles can be separated to create the rectangle. So let's use the formula and see if we're correct. So area equals base times height, and let's label these. Remember, any side of our triangle can be our base, so let's stick with what we would commonly call the bottom. 1, 2, 3, 4, 5, 6. So my base is 6 centimeters. My height, remember, is a perpendicular line from the vertex to my base. 1, 2, 3, 4, 5. So if my area equals base, 6 centimeters, times height, 5 centimeters, and then I'm going to divide by 2. So my area equals 30 centimeters squared divided by 2. 30 centimeters squared divided by 2. So my area is going to be 15 centimeters squared. So according to my formula, my area of my triangle is 15 centimeters squared. So let's go back and try to compare. Let's take our two triangles, and we estimated that our area was 15 square centimeters in our blue triangle. We figured out now that the area is indeed 15 square centimeters. So let's go to the red triangle. My base, 1, 2, 3, 4, 5, 6. My height, 1, 2, 3, 4, 5. We plug these into the formula, area equals, and you're probably saying, well, you don't even have to do that because it's exactly the same, because it's a mirror image, and you'd be right. 6 centimeters times 5 centimeters divided by 2, area equals 30 centimeters squared divided by 2, so my area is 15 square centimeters. So we're correct. Now the interesting thing, if we take the two triangles and we were to put them back together into that rectangle, hopefully you're already saying to yourself, well, if we do that and you ask me to find the area, I already know the area of the rectangle is 30 square centimeters. I know that here we go. All right, so the first challenge I have for you is to estimate, then find the area of this triangle. And I'll remind you that in your notebook, your squares, your grids, if you will, are 1 centimeter square. So when you redraw this in your notebook, assume that each square is 1 centimeter. So I'd like you to do two things. I'd like you to first estimate and then use the formula to find the area of the triangle. And when you're finished, connect to the video, and I have a second challenge for you. Okay, welcome back. I guess you easily and quickly found the area of that triangle and made an estimation, and hopefully you were either right on or very close. Your second challenge now is I'm going to give you the area of this triangle. And I'm going to tell you that the area of this triangle is 12 meters squared. I'm also going to tell you that the base of this triangle is 12 meters. What I'm going to ask you to find is my height. The height of this perpendicular line that meets the vertex and connects it to the base. Find the height of this triangle. You're going to have to use the formula and fill in the values. We'll check your notebooks tomorrow to see how you did. Good luck.